Hey there everyone, this is Coding Cleverly, and today we're going to be talking about the graph data structure. We're going to talk about how it works, how it's constructed, and all the important stuff we need to know about it. The first thing I did was create 3 different files in the same directory. Here I have graph.java, and then we have vertex.java, and we also have edge.java. And what I'm going to do now is I'm going to actually write some code, and then I'm going to try to interlink these all 3 files, because this edge, this vertex, and this graph are going to be used together to create our graph data structure. Before talking about graphs, I want to talk about the graph traversals. There are many ways to traverse a graph, but you will focus on 3 methods: depth first search, breadth first search, and Dijkstra's algorithm. These traversal methods are core algorithms for searching a graph. Now, what are graphs? Graphs are the ideal data structure for modeling networks, making them an essential part of your data structure toolkit. They are made up of nodes or vertices which hold data and edges which connect to vertices. A vertex is a single node. Now all of this will be explained through the diagram. Here's a sample of a graph that I created. These circles everywhere are actually vertices and they're holding data. And edges which connect to vertices. So these lines over here are known as edges, these things. Now I want to give an example. Consider a map of your neighborhood. As a graph, we could represent bus stops as vertices and bus routes between stops as edges. So how about the internet? Web pages can be thought of as vertices and the hyperlinks that connect them as edges. Real-world relationships represented as graphs are numerous, making them an important concept to grasp. The graph we could see over here is actually representing a social network. People are vertices and edges are friendships. So these lines are friendships, these circles are the people. Peter, Cody, and Jordan are all friends. Peter and Cody are friends, and the same goes for Cody and Peter. Peter and Jordan are also friends, and Jordan and Peter are friends as well. So this bidirectional pattern is also existing here. Jordan and Cody are friends, and Cody and Jordan are friends. One other thing that we see here is this thing, which is Caleb and Alex. Now these are friends, but these are not linked with these people over here. Interesting. A path is made up of vertices connected by any number of intermediate edges. From Peter to Cody, the paths could be Peter to Jordan to Cody or Peter to Cody. There's no way between Peter and Caleb. A graph is disconnected when no path exists between 2 vertices. So this here is a disconnected graph because not all of these vertices are connected with each other. It's impossible to reach here, so this is the reason why this graph is a disconnected graph. Alright, so now let's map out this concept in our code. Now what we want to do is we want to create a graph class that could be flexible enough to support directed, undirected, weighted, and unweighted graphs. Now the difference between a directed and undirected graph is that for directed graphs, so this is an undirected disconnected graph. Because there's no link here and you can't reach here, so this is disconnected. The reason why it's undirected is the reason that both of these paths are like bidirectional. So over here, Peter and Jordan is Peter is friends to Jordan, and also Jordan's friends to Peter. So this is bidirectional. So, and this is undirected. If it's directed, it would have arrows here. So it would point that Peter is only friends to Jordan, but Jordan doesn't like him back. And Jordan is friends to Cody and Cody doesn't like him back. So something like that is going to be directed. In case of weighted graphs, you'd have weights on top of each. So I know it doesn't make sense over here, but if we had like bus stops and then their routes, it would have been easy to map out. But here, if I say Peter and then Jordan, it takes like let's say 5. So it's something like this, and then we have over here we have, let's say 10, and over here, let's say it's 12. So over here now we got weights on top of the edges, and these are just going to indicate the number or the expense that we're going to take here. So Peter, I know it's not a good example. Like I said, we could have done with bus stops and routes, but here we're taking Peter is friends with Jordan, and I don't say 5 times. He likes him 5 times. This Jordan likes Cody 10 times, and Cody likes Peter 12 times. I'm not sure if that was a good example, but you got my point there. Something like that, with which associates the numbers as their expenses. With this in mind, we will create our graph with the following requirements. A vertex can store any data, so these circles. A vertex maintains a list of connections to other vertices, represented by a list of edge instances. So we're going to have a vertex, we're going to also have its list to connect other ones. So those are going to be called as these vertices, and they're going to be linked through the edges. So here we have Peter, but friends are Jordan and Cody, right? So we're going to have to put that in some kind of structure here. So it's going to be in a list of edges. So they're going to be represented by a list of edge instances. A vertex can add and remove edges going to another vertex. A graph stores all of its vertices represented by a list of vertex instances. So all of these vertices you see are just going to be stored in that graph structure. A graph knows if it is directed or undirected. Like I said, this is undirected, and if it had some kind of direction, it would have been directed. A graph can add and remove its own vertices. A graph can add and remove edges between stored vertices. With all of that out of the way, let's write the code. So to keep the concepts grounded in a real-world application, we'll build a transportation network of bus stops as we go. What I want to do first thing is actually look into my vertex class. And because I know this is the circle which has the data, and it's also going to have the edges, so we're going to start from this one. Here we're gonna go into this class vertex here, and we're just gonna create some instance variables. So the first thing that I am saying is the private string data. The second thing that comes to the mind is private array list, because we want to store the edges, right? So we say array list, we put the type of the array list here. So we're going to store edges. So it's an array list of edges, and we're going to call this as edges. Alright, so now we're done with that. Let's add a constructor here. We're going to say public, and we're going to say vertex. Here we're going to have a string, and we'll say input data, the data that the user will provide. And then for that we'll say the class variable is equal to the input parameter, and then we have this dot edges, which is the edges, and that would equal to the new array list. And here we want the edge, and we also want this. So here we instantiated the array list, which was this edges one. Now I know this is giving us problems because it's not allowing us to have this, so let's just import this, import java.util.arraylist, and the errors are gone. Here we have a vertex constructor that assigns the data with the input data, and also instantiates the edges list with a new array list of type edge. Now we got these vertices, right? Now we want to have a mechanism that will allow us to see these edges in live action, right? The other thing that I want to go through with this is that I'm going to create this as a directed graph. So there's going to be arrows here. A method called public void add edge. And over here we're going to add in the vertex and vertex and integer weight. Alright, so now that this is done and we just created this constructor for this, know the instance variables, let's move on to edge.java and create the instance variables for here. And then after that we're gonna go back to this vertex.java and finish it up. One thing I want to make clear here is that I'm gonna create a directed graph. It's going to be the ones that have the arrows. It's not going to be the bidirectional ones, which could go both ways. It's just going to be one stop to the other stop, right? It's a bus stop, so I don't want to go backwards. So in this case, it's just a directed graph. What we're going to do here is for the edge, like I said, it's just a line where you see in the graphical representation. But here I'm going to have to try to map it out in code. So I'm going to have the start vertex, where it's coming from, and where it's going to. So private vertex, and then we have the end. And over here we want to weight. We're also going to create this as a weighted graph that will have a cost for how much expense will it take to move from one place to another. Remember those numbers which were on top of those lines? So that's the weight here. So it's going to be a weighted graph as well. So I'm going to put a weight in here as well, and it's going to be called integer. And then when I say WIGHT, I'm going to put a integer weight. And notice I'm using integer and not int. It's the reason is that if I don't want to put anything, I could just type in null, and it would allow me to just like pass it in with no reason. And if I had an integer, I'd pass in something like -1. All right, so now over here we have a constructor, and I would say public edge, and let's create the constructor here. So the vertex, and I'll say the start vertex, so I'll call it as the start v, the vertex, and we have end vertex, so we have end v. We have the integer, and we call it as the input weight, WEIG. So there you go. So we got the start vertex, the end vertex, and the input weight that we're gonna ask the user for. So remember, this is just an edge that we are creating as users. So the class variable this.start will equal to the start vertex, which will be passed in as an input parameter. The same thing goes for the this.end, and it will equal to the end vertex, so we say end vertex. And we have the weight, so we say this.WEIGHT, and we equal it to the input WEIGHT. There you go. So now we're done with this, and let's just add in some other helper methods. So I'm going to be adding some helper methods along with this, and I'm just going to be copy pasting this. So here, these are the public vertex get start, and it's just going to return the start vertex. The public start vertex get end will return the end vertex of the the edge within the edge, and the integer get weight will just return the weight. Okay, so that was cool. Let's go back to the vertex.java file and just make some methods here as well. So for the vertex.java, remember, like I said, we wanted to create a function that will allow us to add some edges, right? We're adding a layer of abstraction here, and we're allowing the method over here will just add edges for us. So what I could do here is I could say a public, and I'd say void add ed, so add edge, so add edge. And if we want to add an edge to a vertex, so remember the current vertex is already in the context, so this will be the end vertex. So I'll just pass in the end vertex here, and also the weight if you want to give it some kind of weight. Remember, I said weight is optional. If you don't want to give it, it will be assigned as null. To do something like that, first of all, I'm gonna have the call to this. I'm gonna say this.edges, edges, because it exists in edges over here. And then there is a function that was called add for the array list, because edges is an array list. And we just add in a new edge, and we call in the constructor. So this constructor will pass in the this. It will get the edges end vertex, so it's going to be end vertex, and will also be the weight of the edge. So all of this will be mapped in here. So this is our add edge, and it's just gonna add some edges here. All right, so now we're gonna have to create the remove edge here. So we're gonna say public, and I'm gonna say void remove edge, and we have vertex, and we have end vertex, and over here we have the this dot edge edges dot remove, and the method for this is since it's edges is an array list, so remove if will allow us to add a predicate and remove all of the elements of this collection that satisfy the given predicate. Errors at runtime, exceptions thrown during iteration or by the predicate are relayed to the caller. Parameter here is a predicate, and here you can read it. It says filter a predicate which returns true for elements to be removed, and I'm gonna add that predicate here. So over here I'm gonna add in so I want to remove that vertex. So here I'm saying remove edge, right? And I'm in that vertex, so I'm in the vertex.java, and I want to remove that edge that was passed in as this one, so end vertex, right? I want to remove that edge from here. So I would say edges dot remove if. Now I'll say I'll remove that kind of edge, right? And then we'll put this arrow bracket. So this is the arrow sign, and we'll say edges, and then we say get end, because we're getting actually two things here. The edges are having two places. One is the first, and the second is the end. So you can see in the code over here we have the start and the end. So the edge has two things, and what we want is the end. So that's why we are getting the second one, and that's going to be over there. So dot get end, and then we say dot equals. So we say if that equals to the vertex that we passed in here, I'm just going to copy that and paste it here. And if that equals, then just remove that from there. So we just need a semicolon here. If I could get a semicolon. All right. And that should solve our problem here. So it's just going to remove that end vertex that we passed in as an input parameter. It's going to look at this edges dot remove if, and it's going to pass in this predicate logic that says find that edge which has the end vertex equal to the end vertex that was passed in. Pretty easy. Okay, so now we're gonna add in some other helper methods. I'm gonna copy paste this as well, so I'll just paste it here. So the first thing, let me just first zoom out and show you what I've done. Here we have this remove edge, and we have the add edge. Perfect. Over here we have this get data method. It's a string return type, and it's just gonna get the data for the vertex. Pretty easy, straightforward. And the array list edge, so this is the return type, and it's saying get edges. So it's just gonna return the edges that the certain vertex has. So it's just gonna return the list of it, this dot edges. All right. Now over here we have a public void print boolean show weight. So over here we have this print method that's just gonna allow us to visualize our implementation, and it's just gonna show us how the graph is looking like inside of our structure. So it's pretty easy. You don't need to go into detail for this, and if you want to write this down, you can pause the video and start typing this in. We're done with the edge.java, and we're also done now with the vertex.java. In fact, I don't even need this main method here, so I'm just gonna remove that here. And now we just have this. So the edge.java and the vertex.java are done. Let's go to the graph.java, the main thing, the main boss. So over here we're just gonna add in the following things. Remember, like I said, a graph is a list of vertices. That's exactly what we want to do here. So I'm gonna say private, and I'm gonna say array list, and I'm gonna put in the type here. The type for this is vertex, because we're putting in vertices. And we're gonna pass in vertices, like this is the name. Now we also have a type which I specified that there could be different kinds, and my graph will be a weighted graph. So I'm just gonna put in a is weighted boolean variable. I'm also gonna put is directed boolean variable, and this is just gonna tell me if the graph is directed with arrows or if it's unidirectional or bidirectional. So that's the thing. Let's create the constructor for the graph, and we'll just say public graph, and then we'll just pass in boolean, and we'll say input is weighted. So the things that are passed in will be determined by the user, and boolean input is directed. So we're done with this, and here we're gonna have the this dot vertices, and we're gonna say new array list, and we're just gonna pass in. So over here we have graph, and then we have boolean input is weighted, and then we have input is directed. So like I said, we have to first initialize the vertices array list. So I'll just say new array list vertex, put the round brackets, and then the semicolon. This will initialize our vertex. This will initialize our vertices list, and for the weighted thing, so we can say is we weighted is equal to, and we say input is weighted, so weight. For the other one, which is directed, so is directed is equal to input is directed. There you go. Cool. So now this is created, and yeah, I have to import the array list as well, so just import that as well. Now let's create some methods, and the important methods that we want to do here is that we want to create a method that will allow us to add add some vertices to our array list, and the name for that will be self-explanatory. It's called vertex, and that's the return type, so it's going to be called add vertex. The data that will be passed in was as a string, and over here we'll say vertex, and we'll say new vertex, and over here we're just gonna create a new vertex here, so we'll say new vertex, and we'll pass in the data that was passed in, and over here we're gonna put that inside of our list, so we'll say this.vertices.add, and we put the new vertex semicolon, and then we have the return new vertex. Cool. So we're done with this. That's the add vertex method, and it just returns us the vertex, so we'll have to assign it to a variable in the main methods. So now we're gonna create the public void add edge method, and this will allow us to pass in the vertex 1, the vertex 2, so this is the start and the end vertex, and the integer weight. Like I said, I wanted to create a level of abstraction here, so I'm allowing our graph to have the add edge functionality as well. So over here it's pretty straightforward. If I said if the thing is weighted, then there's going to be no weight for this, because I passed in integer weight, and I'll have to first check the Boolean variable here. So if I say is weighted, not directed, but is weight. Now if the weighted was false, then so it says if weighted is false, right? So we'll just say the weight that was passed in will be assigned as null. Alright, and if it's not false, meaning if the thing is weighted thing, so we'll say vertex 1 dot add edge, and over here we're actually adding the vertex 2, and here the weight will be passed in as well. And this is the add edge method that's from the vertex class here, so the vertex add edge, this one. Now over here we want to actually add in the other thing around as well, because we need bidirectional and unidirectional. So if it's undirected, then both, right? And if it's directed, then just one. So I'll say if it's not directed, then both. So this dot is directed. If it's not directed, then we'll have the vertex 2 dot add vertex, or yeah, so vertex 2 dot add edge. Here we're gonna add the edge, and we're gonna say vertex 1, and we're also gonna put in the weight over here as well. And there you go. Similar to how we created the add edge method, we now need to create the remove edge method. So let's go here a little down, and let's add the remove edge method. So we're just, like I said, I'm giving the power to the user to do all of this. So, and the user doesn't even have to know how the vertex Java or edge.java works. So that's the layer of abstraction that we're creating here. Remove edge, EDGE, and over here we're gonna pass in the vertex, and we'll say vertex. So to remove the edge, you'll need the vertex 1. You'll also need the vertex 2. Now to remove it, it's pretty simple. We say vertex 1 dot remove. This is the method that was there. So remove edge, and it takes another vertex. And we have the end vertex here, but we're just gonna pass in the vertex 2. And there you go. And then like I said, we have to check if it's not directed. If it's bidirectional, then we have to remove the other way around as well. So I'll say if this dot is directed. So if it's undirected, right? So if it's bidirectional, then we'll have to remove the other way around as well using vertex2 dot remove edge, and we put in the vertex 1. Okay, so that was pretty much it with the remove edge. Now we have some other methods like remove vertex. So I'll just add in a remove vertex quickly over here, void remove vertex. And for the remove vertex, we have the vertex that's passed in as like this. And what we're gonna do is we're gonna say this dot vertices, which is the list that is existing here in this class, this instance variable, and we're gonna use the remove method that's provided by the array list, and we're just gonna remove the vertex that you just asked for, right? So that's just gonna be removed here. Now to save some time, I'm just pasting some helper methods that we also need here, so I'll just paste that in, and let's see how it looks like. So here we have the get vertices, the remove vertex. The get vertices method, it just returns the list. Is weighted, is directed. So that the last thing what we did was this one, which was remove the vertex, and then after that, this one is just a get vertices. It's just gonna return the array list vertex. So the whatever the array list is, it's gonna return all the vertices here inside of that current graph. Public boolean is weighted will return if the graph is weighted or not, and boolean is directed will return if it's directed or not. Public vertex get vertex by value, pass in a value, and it will loop through this for condition. It's gonna go vertex, so you pass in a string value and you're trying to look for that vertex for that kind of value. So let's say I have a stop in New Jersey, let's say Jersey City. I'm looking for Jersey City stop for my bus, bus route. So in the bus service that I'm trying to map out here, let's say I have Jersey City passed in here. Now I'm gonna have to look for that stop if it exists in this entire bus ecosystem. So if it exists in the bus routes, if there is any kind of bus stop that has the name Jersey City, and then it will be returned here. So over here I go for each loop, and it says over here the vertices are list. So I'll say for every vertex v, if the value, so I'll use the get the data value, and this vertex, remember that I created get data over here somewhere, so it's supposed to be somewhere over here. There you go. It returns a data string, and if it equals to the value that was passed in as an input over here, then we'll return the v vertex, and then you'll have it as a vertex here. So perfect. And if it didn't exist, it will just return null. So that will help us know if the vertex exists here or not. And now over here, if you want to print it, so for vertex v in this dot vertices, v dot print, and we have is weighted. So the print method that we created here, this will allow us to see all of these vertices in action. Awesome. Now let's create the main deal here. Let's create some graph. Let's create the graph data structure, and let's try to map it out. And I'm gonna remember I said I'm gonna create a bus station, so I'm gonna say GRAPH, and I'm gonna say bus network, and I'm gonna say new graph, and over here we're gonna pass in for the is weighted and for the directed thing. We're gonna pass in both true. So TRUE and TRUE. Now let me tell you why I did this. The first one was input is weighted. So it is weighted. There's going to be values associated to it. So for every edge, there's going to be some kind of distance. And the input is directed, meaning that there's going to be some kind of arrow, and it's not bidirectional. It's not two ways. It's just one way going forward. So bus network. And I'm going to use the add vertex method that we created here in this method. So it asks us for a string data. And we'll just say, let's say Clifton. And here we have it, semicolon. But remember that this add vertex method, if you go and see the method here, it's actually returning a vertex. So we're going to have to store in some kind of variable. So let's store it in a vertex. And I'll call this as Clifton Station, and it equals to that. So there you go. And the same goes for the next one. So I'll say bus network dot add vertex, and we'll say vertex. And over here we'll have the next station. I'll just add a Cape May station, and let's have the vertex here as well. So Cape May station, and just there you go. So we created 2 stops, and I think that's enough for now. So now what we have to do is add the edges and the connections between them. So we use the the add edge method. So we'll use bus network, and we'll say add edge. And to add edge, we have to put one station to the next. So we'll say Clifton station, and we'll say the Cape May station. So that's the connection, and we'll also have to put a weight. We'll have to put a weight as well. So I'm gonna say it takes 1,000 miles to reach there, and that's our weight. Cool. Now it's connected, and remember that I'm not putting it. So I'm just putting it one way, and it's just gonna connect it directed way. Here we have that. If I wanted to remove an edge, it would remove it using the same, but I'm just gonna say bus network dot remove edge and just pass in the same 2 things, not the weight that time. In this case, I just want to print it out and see how it looks like. So bus network dot print, and this is our method that is created here, and actually calling all the vertices. So it's going to be printing it through here. Awesome. So let's run this baby up and see how it looks like. So I'm gonna command prompt here, and I'm gonna say Java C. The name of it is called graph.java. It compiled, and now after that, I'm just gonna paste here. So over here we have the direction from Clifton to Cape May, and it takes 1,000 miles. So that's exactly what we did here. Let me just minimize it quickly and go back here. And if I look over here, I actually created a direction from Clifton to Cape May, and it takes 1,000 miles. And I didn't do the other way around. Like I said, this was not undirected. It was directed because it was set to true. And here you can see that there's just one way from Clifton to Cape May to 1,000. And I can't go from Cape May back to Clifton. And if I want to do that, I could easily do that. I could just modify this. So input is weighted. That's set to true. If I just leave this as nothing, so by default, it will consider that as false. So, all right. So I'm just gonna have to, if I add in false here, and that's just gonna make it undirected. So it's gonna go both ways around. And if I do this now, it's gonna go bidirectionally. So I'll say this, and then after that. So over here we have Clifton to Cape May 1,000, and Cape May back to Clifton 1,000. Awesome. So that was pretty much it with this video. There's a vast Java directed graphs. All right. So that wraps up our graph video. If you liked this video, enjoyed it, and learned something new, then definitely leave a like and subscribe to the channel and be a part of the Coding Cleverly family. All right. So that was it with this video, and I'll see you guys in the next one.